Hello, dear students of class 7. Welcome to online classes from LPM Public School, Gola Bajar, Gorakhpur student. I am a science teacher. Dear student, today I will explain you about the effects of the current, in which in my previous class I have explained you about the fuse. What is the work of the fuse? Student, as I have told you, fuse is the that appliances which is applied in the circuit of electric current to break the circuit if there is a heavy power electric supply. If comes due to some reasons, the wire that is present inside the fuse that melts and break the circuit, and in these conditions the many appliances that runs on electricity become safe from being damages. So student, now my today's topic is fuse rating. So the fuse rating is the maximum current that the fuse can carry without melting. If what happens, suppose that if the wire in that fuse is more powerful than the normal wire which is present in the circuit, then the fuse will not melt and it will allow the current to pass to the other side. And in that conditions, the appliances will get damaged, as because the wire that is present inside the fuse is of high power holding capacity. Usually two types of electrical fittings are available in the market. One meant of maximum current of 5 ampere and the other for a maximum current of 15 ampere. So student, there are two types of electrical fitting. One is of power of load power of 5 ampere and another is a 15 ampere. The fuse is the lightning, and the fuse in the lighting and fan circuit of a small house is maximum capacity of 5 ampere. In a normal house where the people of that house used to just use the fan and light bulb, so in that case the wiring, the fuse that is present in his wiring is used of 5 ampere, which means that the fuse will melt if the current exceed with 5 ampere value. The fuse used in the power circuit of a small house for running electric stove, geyser, and the that house that consume more power, and the just like geyser, electric heater, you can say induction, this type of, if all gadgets are being used in that house, that means he's consuming having the power of 1000 watt or more. So in that condition, the fuse that is used in those houses must be of the capacity of 15 ampere, so that it could bear the burden up to a 15 ampere. And if it will be more than 15 ampere, then the fuse circuit will melt and in that house the electric supply will break. Next one, the cause of large current flow. What is the reason behind the sudden huge amount of charges start coming to our house that damages the home electrical appliances? So there are two certain reasons. One is the short circuit, student, another is the overloading. So I'm going to explain about the short circuit. The touching of live and neutral wire, means the touching of positive and neutral wire directly is the live, and the positive neutral wire directly is known as the short circuit. If that wire directly touches each other, comes in contact with each other, there it causes the short circuit. This means if the insulation on the wire has come off due to the wear and tear, if suppose there is no covering on the wire and that come in touch with the other neutral wire, both the after coming in contact, it will produce a heavy charge flow, and this causes short circuit that could damage the, that could lead the heavy power flow in the circuit and could damage the electrical appliances or the gadgets. Next to an overloading. When too many appliances are connected in a single socket, they draw an extremely large current from the household circuit. This is known as overloading, and in that case, when when it just pulls a heavy power, in that condition the fuse which is wire which is applied is of low power than the capacity of the which the electrical appliances is pulling the power. So in that condition also the fuse melts, as because more power is just pulling from the more power is just going to come inside the house appliances, and to bring it to make it safe, the fuse wire melts in this condition. So here I have explained, student, what are the causes behind the large current flow: short circuit and overloading. These are the two main reasons why there is a causes of large current flow. Next, student, circuit breaker. Miniature circuit breaker. Nowadays in the home electrical gadgets appliances, that is which is used by the side of your main board, from where the from the pole region where the wire comes, main cable comes there, the cable is inserted inside a circuit breaker that is called the miniature circuit breaker, MCB. There was one time where in place of MCB the fuse were used. Those fuse which were made up of porcelain of different power, 10 ampere, 15 ampere, they were used. But nowadays mostly in place of fuse, MCB are used. That is the full form of MCB is miniature circuit. M for miniature, C for circuit, B for breaker. A circuit breaker can be used in a place. MCB, standard or miniature circuit breaker, is a circuit breaker if the current exceeds a certain value. Suppose that how much the power that have been allotted to your house. If some gadgets you are applying at the house which is pulling more power than that, the power of that cable, so in that case the this circuit will break by the automatic falling of that switch of the MCB. And it could very easily, when you just again on the switch, again the supply will come. In the case of fuse, the wire used to melt, and we have to open and again just tie the new wire in that. Okay, behind that there we have to do much work, but in this case not so much. Its task is very easier. You just fall downs, and when you control the heavy work of any appliances, and you when you switch on again the miniature, it will again start giving the power supply to your house. So it is safer and easier to use. So MCB breaks the circuit like a fuse, but the work is same. The work is same as that of the fuse. Fuse also break the circuit and MCB also break the circuit. Its only difference is that it melts, and here the only the switch falls down, switch become off like a fuse to avoid, and this the task is same to avoid it from fire setting. These switches automatically turns off when the current in a circuit exceeds to the safe limit. Once you turn them on, the circuit is once again completed. It doesn't work on the heating effect of its formula of working is different from that of the simple porcelain fuse, which in which the wire used to get melts and break the circuit. So it works on the magnetic effect of current. One thing I want to see a student that look here, a simple knowledge question is here. Paheli took a wire of length 10 centimeter and Buzo took a wire of 5 centimeter of the same material and thickness. It's made of same material and same thickness, but the length is differ here. One length is 10 centimeter, other length is 5 centimeter. Both of them are connected. Both of them connected the wire as shown in the circuit given in the figure. The current flowing in both the circuit is the same, and the current ampere is also same. So the question arises that will the heat produced in both the cases be equal? Because as you know the when the current flows, okay, it produces a heating effect that I have already told you. So this question has been asked, will the heat produced in both the cases will be causes be equal? And the explanation is that amount, no. Here the explanation is no. No, the amount of heat produced in both the cases will not be equal. Why so? Amount of heat produced in wire depend upon the length of the wire. So you can see here, student, that the amount of heat produced in both the cases will not be equal. The amount of heat produced in the wire depend on the length of the wire. That means the wire the wire whose length is more, that produce much heat, that in this case the heat will be more, and in the other case, as the wire is small here in this case, so the heat will produce less. So here is clear, student. The case in which the wire length is more, it produces more heat because it's can hold much electric current in it, as because I have already told in my previous video about the resistance, means holding capacity. If the wire is of greater length, then the current flow between that greater length will be more than that in compare with the smaller length of the wire. So the wire that has bigger length can create more heat than the wire of smaller length. Next, student, uh, one more question: will the heat produced be same? Will the heat produced by the 10 centimeter wire and the 5 centimeter wire is same if the wire taken by them are equivalent, but if the wire taken of equivalent but it is of different thickness? Now here, suppose both the wire is of 10 centimeter length, but the difference is that the thickness of the wire, one wire is more than the other. So in that case also, the wire which is more thick, in that wire more current could flow than compared to thin wire. So you can see here, no. The second answer question, answer may be no. The amount of heat produced in the wire depend on the thickness of the wire. That means the wire that is thick enough can pass greater electric current than that of the wire thin wire. Okay, student. Next question, student. On what factor does the heat produced in a wire depend? The heat that is produced in the wire depends on which type of factor? So you can see here, student, the heat produced in a wire depend on the current flowing in the wire and the resistance, means how much current is coming in that wire, and the resistance, how much holding capacity is that of what holding capacity of current in that wire that creates the heat. Okay, student. Now, student, come on the next topic: magnetic effects of electric current. Student, magnetic effects of electric current. I will start the next topic. In this topic, when an electric current is passed through a conductor, when a conductor through which electric current passed, that conductor behaves surrounding it, that creates a magnetic field has been set up around it, which exists as long as the current flow, and that magnetic field will remain there until and unless the switch is off, or until the current is flowing in that wire. Till then, till the current is flowing, till then the wire surrounding it behaves, creates a magnetic field. But as soon as you switch off the wire, the current stop flowing and the field disappears. Means when an electric current is passed through a conductor, a magnetic field is set up around it, which exists as long as the current flow in the conductor. This is called the magnetic effect of the electric current. Means, student, again I want to repeat: when an electric current is passed through a conductor, a magnetic field, a type of such field that has got the attracting power like a magnet, so it's called magnetic field, is created, or you can say set up around it, which exists as long and this magnetic current will exist there, present there, as long as the current is flowing in that conductor. And this process, this factor is called the magnetic effect of electric current. This effect was first observed by Hans Christian Oersted. So this effect was first observed by the scientist who H.C. Oersted, that is Hans Christian Oersted, in 1777 to 1851. He observed this, he done these observations, and professor who was the professor of physics at Copenhagen, that is in Sweden, in 1820. He was a professor who just made an experiment and observed that the magnetic effect of when an electric current passes through a conductor, that arises a magnetic effect. Now student, let's see his experiment, what he has done. Oersted, Oersted experiment. Oersted's famous experiment consists of a conducting wire. First, he taken a wire through which a current could pass, that is called the conducting wire. He has taken a compass needle, a battery, and a key. The conducting wire AB, you can see here student in the diagram here, the wire AB. This diagram you can see here below. So where the connecting wire AB is connected to a battery through key. There is also a key means switch here also. Key here with the battery. This wire has been connected. Now the connecting wire AB is connected to the battery through key, and wire is arranged above the magnetic field, and there a compass needle means magnetic compass has been put there by side of that connection, that wire. Okay, parallel to the, in this situations, in the parallel way of the wiring. Okay student, the needle both are along the north and south direction, and as you must see that the needle is always in the north and south direction when the wire behind beside this doesn't pass any, when the wire is neutral, no any current is flowing, till then the magnetic needle just point toward the north and south. Okay, but as soon as you switched it off, the key is on. You can see in the second figure, the key is on student. You can see here the switch is on, that means the circuit is complete. And as the circuit is complete, you can see the needle has been got deflected. It is not in this condition no more, it got deflected. Okay student, and as much as you can pass the electric current, you can see there is a more deflection. There is a more deflection of the poles, magnetic, due to the magnetic effect of the electric current. So when here you can see K stand for key. When in the key K is open and there is no current in the wire, the magnet remain parallel. And when the key is open here, you can see here the key is open, and when the key is open, there is no deflection in the compass. But when the key is closed, there you can see the deflection in the compass. As well here also you can see the deflection in the compass. So when key is open or there is no current in the wire, the magnetic needles remains parallel to the wire. Both remains in north and south directions. That means there is no deflection. But when key K is closed, when the key which is denoted by the alphabet K is closed, the circuit begins to flow in the wire, and the magnetic needle get deflected. Okay, it is no more in north and south direction, but it get deflected and take a new position. When the current in the wire is reversed by changing the terminal, suppose that we have changed the terminal, now positive to negative and negative to positive. In that case of the battery, the needles get deflected in opposite directions. Now the needle, as the current, the flowing of current get reversed. First, suppose that from left to right it was going, now it is going from right to left. So in that condition, the deflection of magnetic needle will also change its direction. Just you can see here student, here you can see the arrow marking how it is going there, and here you can see the arrow marking from north to south, and here from south to north. Here it is going from south to north, and here it is going from, you can see here student, from north to south. Okay. So this when we have changed, you can see here this changing, you can see here the changing is from here. Sorry student, here is changing, you can see at first the positive was here and the negative was here. Now the positive is here, the negative is here, you can see here student. So when the direction of terminals has been changed, the direction of flowing of current also got changed, and as the direction of flowing of current changed, the deflection mode of the needle has also been changed student. So by this observation you have find the deflection of needle increases by this observation. Oersted concluded that since the magnetic needle can be deflected only by another magnetic field, so this magnetic needles get deflected only when by passing of electric current there produces a magnetic field. This magnetic field could only deflect the magnetic needle. Therefore, the current in the wire must be producing a magnetic field. As the electric current is due to the moving charges, therefore we may say that a moving charge produces a magnetic field. When there is no current flowing in a conductor, there is no net magnetic field. Now, student, as the electric current is due to moving charges, therefore we may say that a moving charge produces a magnetic field. That means through a circuit, when a current flows, surrounding the circuit there is a magnetic field created. When there is no current flowing in the conductor, there is no any magnetic field. So magnetic field is produced when the electric current flows in the conductor. Here's a small activity student that is going to show that when the electric current is passes through it, it could create a magnetic field that is shown here. Here you can see here for proving this experiment, something has been taken here, that is what is the material required. A metallic wire is required here. Okay, a dry cell or a generator, switch, magnetic compass, connecting wire having crocodile chip clip. This is called the crocodile clip, which is just not shown here. Hmm, student. So as it ends and sandpaper. Now connect the metallic wire to the dry cell. So you can see here the metallic wire, this wire is connected with the dry cell. Okay, now with a switch using the connecting wire having the uh, having crocodile clip at the end. Now here you can see this is connected with the switchboard. You can see here, place the compass needle, and now this is the compass needle which has been placed between the wire. Okay, or over the wire. Now close the switch. Now close the switch and observe the deflections of the needle. If any deflection has been done, then it's proof that yes, current has flown. If any deflection has been seen in this magnetic compass, that means if there is a flow of electric current, and that has been created a magnetic field. Open the switch and again observe the needle. Again open the switch and again observe the needle of the compass whether the deflection again come back in the initial position. So as soon as you switch it off, the magnetic needle will come in the previous position. So again switch it on, again you will see there is deflection. That means it is clear that as the current starts flowing, there arises a magnetic field around the wire that used to deflect the magnetic compass. The deflection of needle shows the current carrying conductor act as a magnet. So student, the magnetic effect can be increased if we use long coil. So on which the magnetic effect depend, you can see here clearly it has been given that the magnetic effect the magnetic effect can be increased if we use a long coil. As much as the coil is long, that much more amount of current, okay, electrons has been filled up inside that wire, and that will conduct more power. So as there's more power, there's a more deflection of magnetic in the magnetic field, there's more effect of magnet. The magnetic effect can increase if we use a long coil of wire instead of a straight wire. Long coil wire means long, and the wire must be coiled like this way. Okay, that means it is giving more resistance in compared to the straight wire. So here in this condition, the magnetic field will be more than in compared to this. So student, that's all for today. Thank you. Have a nice day, student.